For the next unit, force and laws of motion. Unit chapter number unit 9 or chapter number 9 from your text. Okay, in the previous class we discussed about uniform motion or motion along a straight line and their position, speed, average speed, velocity, etc. Now, to produce motion, what is necessary? Or to change direction, what is necessary? Or to change the direction of a moving body, what is required? Or to change, for example, a trolley is pulling, a door is pushing, or a moving ball changing to other side. Here are what is, these are producing certain costs. To produce these costs, what is required? What is actually required? They required a force. Or when we pushing a rubber band, or pulling a rubber band, or pushing a balloon, or compressing a sponge, there are producing a cost. To produce a cost, what is required? A force is required. So, there we studied what is actually force. Force is a quantity which may be a push or pull, which can change speed or rest of a body or direction of a body or shape of a body or size of a body. So force is a push or pull. What are the things that can do? That can change the shape of a body, size of a body, or direction of a body, speed of a moving body, or rest of a body. Now, we know there are two different types of force. One is balanced force. See, suppose a box is placed here. Here, two boys pushing this box equally from both sides. Then the box is not move. Here the box does not move. Why? Because here the force applied is which type of force is here we applied? They are applied what type of force? They applied balanced force. Suppose we know a unit of force is Newton, and suppose we applied 5 Newton to this side. That means towards right. And here also applied 5 Newton force to left. That means that force. Now these two forces are equal and also in the opposite direction. Hence this force is a balanced force, and it does not change the rest of this body. Now suppose the force towards right, now it will be 6 Newton, and force towards left is 5 Newton. In which direction is force more? Towards the right it is more. So here if we take a net force, that will be 1 Newton, and it is towards the right. So this force is an unbalanced force, hence the body move towards this side. Hence the body move towards this side. Suppose here one picture is given in your text. Some two boys pushing a heavy box from one side with a lesser force. That box is not moving. Then they move, then they push it harder. Then also it is not moving. When they are pushing again still harder, then that box is started because there is the unbalanced force. At first, when they push that box with a lesser force, that is not moving because there is a pushing force and a frictional force. They are acting in the opposite direction. That is not moving. And when they push it a bit harder force, then also it is moving. Then also it is not moving. Then also it is not moving because there also it is balanced. Which are the one is pushing and another one is friction acting in the opposite. When the pushing becomes harder more, that starts to move because there is unbalanced force, that is pushing force is greater than friction, so that one is moving. And if the pushing force stops after some time, then that way comes to a rest. But that means by observing this, we came to one point, that is, if there is an unbalanced force or to move a body, there must be an unbalanced force. But by observing the video, the motion of a marble on an inclined plane, Galileo, by observing the motion of a marble on an inclined plane, see, he placed a marble on a smooth inclined plane like this. Here is the marble. This is another inclined plane. See, when this marble released from this, it starts to roll down and its speed gradually increases. And when it comes to, that means it rolls downward and it moves up. If these two planes are equally inclined, then this marble goes to the same height. This marble goes to the same height as from when it comes down. And if the angle of this side, if we decrease gradually like this marble will move for longer distance and it will move still to attain the same height. And if this surface being made a horizontal plane, then it moves till to attain, that means this will move and up to when it attains where the same height. That was his findings. But actually, this does not move for a long time. Why? Because there is unbalanced force. If there is no unbalanced force, then this will move. A body under uniform motion, that will continue its motion forever. That was his consideration. If there is no unbalanced force, this marble will move on through this horizontal plane. But actually, this is not happening because there is not unbalanced force, because there is friction. There is friction. If we reduce friction, the distance traveled by this marble will become more and more. But we cannot make a surface or a body without friction. A body without friction we cannot produce, so it will stop after some time. By observing these Galileo's ideas, Newton put forward and studied about the force and motion. By observing these Galileo's ideas and some other things about the force and motion, that is based on Galileo's motion on inclined plane and force. Newton put forward 3 laws, and about that first one, that is Newton's first law of motion. We can do. Newton's first law of motion. See, suppose if an object at rest, suppose a stone placed on the table, that will remain for long time if there is no force act on it. Similarly, in the case of a marble, that marble, when it comes down, speed increases and moves at that more type of, and then its speed decreases. And so, see, the motion of it continues for a long time. Motion of it continues for a long time. To change its motion or state of rest, there must be an unbalanced force to change the state of rest or uniform motion along a straight line. Change the state of rest or uniform motion along a straight line. There must be an unbalanced force. This is the Newton's first law of motion. Which is the Newton's first law of motion? To change the state of rest or uniform motion. What are the things? State of rest or uniform. Uniform motion along a straight line. To change the state of rest or uniform motion along a straight line, an unbalanced force must act on the object. In the case of an object, if it is in the state of rest or uniform motion along a straight line, to change these two, there must be an unbalanced force. This is an example of what Newton's first law. This we come to from Newton's first law. But actually Newton's first law states to change the state of rest or uniform motion along a straight line, an unbalanced force must act on it. An unbalanced force must act on it. Suppose if there is no unbalanced force act on it, if there is no unbalanced force act on it, then its state of rest does not change. That will remains there. Or uniform motion, if there is no force, that will not change its uniform motion. So it comes to the term inertia. Inertia means it is the natural tendency to resist. Inertia is the natural tendency of a body. Inertia is the natural tendency of a body. Inertia. Inertia is the natural tendency of a body to resist its state of rest or uniform motion and its change. What actually inertia does? It resists the change. Inertia resists the change It is state of rest or uniform motion along a straight line. What does inertia do? Inertia is a natural tendency. It resists the change of its rest or uniform motion along a straight line. So, now actually see here. Now we can come to some examples. Suppose some carrom coins placed. Suppose in a carrom board, so many coins are placed one above the other. Similar, identical carrom coins placed on a carrom board. Suppose the bottom or be hit with a striker, then this will move, but all other come to the same point here itself. That means to understand the state of rest or inertia of rest, to understand inertia of rest, what we can do on activity, arrange the carrom coins, one over the other as a point. Then the bottom of the coin we strike off with the striker, then all other will come to the same point in the vertical level or vertical height. This is because when we strike the bottom of the bottommost coin, that goes away. All other will come to the same state due to its inertia of rest. Similarly, see here is a glass. This is a cardboard. See, a coin is placed, a 5 rupee coin is placed above this. When we strike off this, see, once again, the coin is here. You can see this one. See, I strike off. This coin is coming because this also due to inertia of rest. Why this? Once again you can see this. This cardboard glass, cardboard and coin. See what is happening here? Before I strike the cardboard and the coin were at rest. Both were at rest. When I strike the cardboard, it moves, but the coin tried to be at rest. Now here is no cardboard, so it fell into the glass. This is due to inertia of rest. Now see here and one more. You can see water in this. When I am moving this, see water is throwing away from this. See, when I am rotating this, you can see here water is pouring. That means water is throwing out of this. Why? This also due to inertia of rest. Some other examples also we can discuss. This two activity shows what is inertia of rest. Because when I am moving this, that means glass with the water in a round glass and water were rest. But when I move this one, trying to be at rest because it that is spillover. Now you will also experience this inertia when you traveling by bus. When a bus at rest suddenly starts to accelerate. When you are standing in a bus and when it starts to suddenly accelerate or move forward, we fell backward. If we are not catch the bus, we surely fell down. Why? When the bus starts forward, our feet starts to move along with the bus. But the upper part of the body still continue to be at rest due to inertia because of we fell backward. And in a car, when the car moving along with the car at the same speed. When the brake is applied suddenly, what happened? The car stops. Along with when we are sitting, that part also stop, but the upper part of the body still continue to be in motion. So we move forward and we may hit the panels and can get injured. But when we wear seat belt, if we are in seat belt, then that seat belt offers some force, and that force help us to move forward slowly. So we may not get injured. And that is why we must wear seat belt while traveling in a car. And another example, when we traveling in a bus, when the bus turning speedily a car, we thrown to one side. Why? Because of inertia motion, we continues to be in the straight line. But the bus, we try to be in this straight, but the car is or bus is taking curving this one. So this curve we throw this way. That is why we are pressing to one side when the bus or car taking in a car. Okay. Another example here given. Here it is suppose when we observe teacup in a saucer, that means there is on grooving. That is, if the saucer is moving, then suppose if there is a jerk, because of that it can topple down. To avoid that one is there is a groove in a saucer, and at the bottom of the cup there is a groove also. That is to avoid what is toppling down of the cup. This saran shows that there is inertia of rest and also inertia of motion. Now, how this inertia of rest or inertia of mass depends on mass. If there is any relation between inertia and mass, now we want to find out, is there any relation between inertia and mass? For example, suppose we want to hit a football. We can easily hit it because its mass is small. If we are trying to hit a stone of same size, is it possible to hit it in the same way and can give it the same speed? No, it is not possible because a football, its mass is small, but stone, its mass is large. So we cannot hit and speed up in the same way a ball and stone. So here the stone with the inertia of rest is small, but here inertia of rest is small. In the same way, suppose we want to move a trolley by pushing and to get the speed of suppose 1 meter per second. Inside we want to get it, give acceleration to it. In the same manner, suppose we want to push a car and make it speed of 1 meter per second square. Is it easy for a car? Suppose we want to push this car and to give its speed at the rate of 1 meter per second square. But here we can give because its mass is small. But here it is not possible because the mass of the car compared to trolley is very large. So, mass and inertia are interrelated. So, we know inertia is the natural tendency to resist. What is actually inertia? It is the natural tendency to resist its change of rest or uniform motion along a straight line. And it depends on mass. So when the mass increase, inertia of the body also increase. When the mass decrease, inertia also decrease. That we can understand from these examples, because to move a ball it is easy, but to move a stone of same size it is difficult because its mass is small. Hence its inertia is less. In the case of a trolley and for a car or a train, comparing to a trolley and train, to move and to get the speed up of this much is very difficult because mass is large. So inertia depends on mass. When the mass is more, inertia also more. Now some questions related to this we can answer from the text. First one, which of the following has more inertia? A rubber ball and a stone of the same size. Which will be? You can say answer. Which of the following has more inertia? A rubber ball and a stone of the same size. If I say rubber ball, you will agree? Will you agree with me? No. Because mass of the rubber ball is smaller than mass of the stone. So which one has got more inertia? Inertia of the stone is more. Then second question, 5 rupees coin and 1 rupee coin. Suppose a 5 rupee coin and 1 rupee coin. Among these, which one has more mass? 5 rupee or 1 rupee? Mass of 5 rupee is more. So its inertia is more. Now, second question, in the following example, try to identify the number of times the velocity of the ball changes. In the following case, one example is given. Try to identify the number of times the velocity of the ball changes. See, a football player kicks a football to another player. In his team, suppose a football player kicks a football to one of his players. Now, see, a football player kicks a football to another player of his team. Who kicks the football towards the ball? Now, see, here is a football. One kick to another. He kicks towards the ball. Now, a football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Now, here is a goalkeeper and he kicks to a player of his team. Now, here to here direction ball is changing. This direction ball is moving on. Here is moving. And suppose the football, then this goalkeeper kick it towards here. Now, how many times the direction changes? This to 1, 2, 3 times. If this one to here one direction, second player, this goalkeeper to here. Now, see 1 here, 2 here, 3 times the direction changes. Or direction changes means velocity also changes. And now third question, explain why some of the leaves may get detached from a tree if we vigorously shake its branch. When we shake vigorously the branch of a tree, some of the leaves fell down. Why? It is due to inertia of rust. It is due to inertia of rust. Before we shake the leaves and the branch were at rest. But when we shake the branch start to move, but the leaves tries to be at rest. Because of that, it gets detached from the branch. Its answer is what is inertia of rust. And fourth question, why do you fall in forward when a moving bus brakes to a stop and fall backward when an accelerator from rust? Suppose when a bus is moving forward, we move along with the bus. When the brake is applied, bus stops. But when the bus stops, our feet also comes to rest along with the bus. But the upper part of the body still continue to be in motion. Upper part of our body continues to be in motion due to inertia of motion because of we fall forward. When a bus suddenly accelerated, a bus at rest when suddenly accelerated, bus and the passengers were at rest. When the bus suddenly moves forward, the lower part of the body is at lower part of the body also moves along with the bus, but the upper part is still continue to be rested due to inertia of resting. So fell backward. These are the questions given to discuss what are the things we studied, what were the things we studied from that these questions. If you find any difficulty in this question, you can ask to me later on. From first law of motion or law of inertia, we find that when a force is applied, velocity of the body changes. From first law, we came to know that when a force is applied, velocity of the body changes. That means the body is accelerating. Accelerating means its velocity increasing. Suppose a moving table tennis ball falling on our body. We may not find any problem or we does not feel any pain. But instead of a cricket ball which is moving with a great speed, when it is hit on us, we find it is very hard or we feel very painful. Okay, in a similar way, we know what is a bullet of mass is very small. But that small bullet can kill a person because of its velocity is very high. Its velocity is very high. Here the difference of table tennis ball and cricket ball, both are moving at the same speed, then here the mass is very large. That means for a cricket ball, mass is large compared to a table tennis ball. In the same manner, see here a bullet, if its mass is very small, but its speed is very high or its velocity is very high, so it can kill. Velocity is very high, so it can kill a person. See a truck that is at rest on the roadside, that may not harm to us or anyone. But if it moves a small speed, suppose for example 5 meters per second, then also we can kill a person. Why? Because its mass is high. So when we consider the motion of an object, we must consider its mass and also its velocity. So there is a quantity which is related to mass and velocity of a moving body. There is a quantity which come here. We want to consider that is momentum. Momentum is the property of a moving body. What is actually momentum? It is the property of a moving body or moving object. Momentum is the property of a moving object. Momentum is the property of a moving object, and it depends on mass and another term, what is velocity. Mass and velocity. Momentum means it is the property of a moving body and it depends on mass and velocity. So momentum V is equal to m into v. M mass of the body and v is velocity. This momentum is a vector velocity. Momentum is a vector. Which is the direction of it? Its direction is same as that of the velocity. Velocity and momentum are in the same direction. What is the unit of this one? Unit of mass is kilogram. Unit of mass is kilogram. And unit of velocity is meter per second. Velocity is meter per second. So unit of momentum is kilogram meter per second. Kilogram meter per second. This is the unit of momentum. Now you want to remember about what is momentum. It is a property of a moving body and it depends on mass and velocity. So P is equal to M into V. What is the unit? Kilogram meter per second. Is it a vector? Yes, it is a vector. What happens when the mass of a moving body increases? When the mass of a moving body increases, its momentum also increases. If the velocity is increases, then its momentum also increases. Now, see, today we discuss about the first law of motion. And from that, first law of motion, what it says? What is the first law of motion says? What is its statement? That means every body, that means even a book or a bus or a car or all things, every body continues in its state of rest or uniform motion along a straight line unless an external force acts on it. Unless an external force acts on it. Then we come to Galileo's observation. What did he observe? If there is no unbalanced force acts on a body, if there is no unbalanced force acts on a body under uniform motion continues in its motion, Then we come to what is inertia of rest. What is inertia of rest? What is actually inertia of rest? Every body at its rest continues in its state of rest. And to understand this, what we did with this cardboard coil activity, then another one with a glass filled with water and a tray. When the tray moves, when we rotate the trays, what happened? The water in it fell or split. Why? Because water remains at rest before, but it tries to be at rest, but the glass is moved forward, because of that it fell. Then inertia of motion. Example for inertia of motion is what is when the moving bus suddenly stopped, we fall forward. And another example, when a car is moving, what happened? When the moving car is suddenly stopped, we moved forward. To avoid it, we wear seat belt. Another example of inertia of motion is what is a moving car when take a cover, we throw to one side because we try to be in the uniform motion on straight line. Because of that happen. Then we come to another term. What is it is the momentum. Momentum depends on two factors, which are the momentum depends on mass and velocity. Which are the terms? Mass and velocity. Mass increase, if the mass is increased, then momentum also increased. What type of quantity is momentum? Momentum is a vector. How to calculate momentum? The product of mass and velocity. The product of mass and velocity. What is the unit of momentum? Its unit is kilogram meter per second. Kilogram meter per second. Then now we discussed completely about first law of motion. Now we want to go to second law of motion, that we can discuss in the next class. Okay, with this we can wind up today's class.